Hello friends, welcome back to my channel. Are you ready to tackle today's math challenge? Yes, in this session we will explore an intriguing sequence problem that sure will test your problem solving skills. Let's dive in. The problem statement goes like this: given f of n is equal to 5 plus 3 root 5 divided by 13 multiplied with 1 plus root 5 by 2 whole power n plus 5 minus 3 root 5 by 10 multiplied with 1 minus root 5 by 2 whole power n. So the problem statement is that given this f of n, we have to express this term, which is f of n plus 1 minus f of n minus 1 in terms of just f of n. Okay, so that's the problem. So let's look at the solution. So to solve this, what is that we have to do? We have to break the problem into simple steps. Let's assume that the first term, which is, the 1 plus root 5 by 2, let's assume that to be alpha, and the term in second, the parenthesis term in the second term, 1 minus root 5 by 2, let's assume that to be beta, and 5 plus 3 root 5 by 10, let's assume that to be a, and 5 minus 3 root 5 by 10, let's assume that to be b. So by substituting them, we can write our f of n as a times alpha power n plus b times beta power n. Okay, so we got this result. What is that? We wrote f of n in terms of a alpha power n is equal plus b times beta power n. Now let us evaluate the actually asked term. What is that? F of n plus 1 minus f of n minus 1. So let us solve that. So what is the first term? It is f of n plus 1. So how do you get that? In f of n, we replace n with n plus 1. So you get a times alpha power n plus 1 plus b times beta power n plus 1. Similarly, what will be our f of n minus 1? That would be a times alpha power n minus 1 plus b times beta power n minus 1. So what is that is asked? We have to evaluate f of n plus 1 minus f of n minus 1. So let us evaluate that. So we just substitute them for f of n plus 1 this term and for f of n minus 1 this term. So because we have a minus here, so what happens? We get minus alpha power a alpha power n minus 1 minus b times beta power n minus 1. So you look at the first term and third term. What is this common for us? A times alpha power n minus 1 is common. So what happens if you take a times alpha power n minus 1? So we get alpha square minus 1. So that is bit from 1 and third term. And similarly between second and third term, what is common? B times beta power n minus 1. So what happens? The factored term would be beta square minus 1. Okay, so everything now boils down to evaluating alpha square minus 1 and beta square minus 1. So let us see that. So just now, in the beginning slide, we have seen that alpha is how much? 1 plus root 5 by 2. So let us substitute that. So alpha square would be 1 plus root 5 by 2 whole square. By expanding out the numerator, we get is 1 plus 5 root 5 whole square is 5 plus 2 times root 5 divided by 2 square, that would be equal to 4. So numerator would become 6 plus 2 root 5 by 4. So 2 is common. So finally you get 3 plus root 5 by 2. Okay, so but we have to evaluate alpha square minus 1. So alpha square we got 3 plus root 5 by 2 minus 1. So that should be equal to 1 plus root 5 by 2. But we already know that 1 plus root 5 by 2 is how much? Alpha. So what is that we got? We got alpha square minus 1 to be equal to alpha. Similarly, let us evaluate beta square minus 1. So to do that, first let us evaluate beta square. What is beta? Beta is 1 minus root 5 by 2. Again, recollect this from the first slide. So you get beta square to be 1 minus root 5 by 2 whole square. Again, by expanding out, you get 1 plus 5 minus 2 root 5 by 4. And again, numerator is 6 minus 2 root 5 by 4, and hence 2 is common, that get cancels out, and hence you get 3 minus root 5 by 2. But we want beta square minus 1, so that should be equal to 3 minus root 5 by 2 minus 1. So that should be equal to 1 minus root 5 by 2, which is same as beta. Okay, now let us go back to the original expression. which is f of n plus 1 minus f of n minus 1. Recollect that we have got this term to be equal to how much? A times alpha power n minus 1 times alpha square minus 1 plus b times beta power n minus 1 times beta square minus 1. So just now we have evaluated alpha square minus 1 to be alpha and beta square minus 1 to be beta. So let us substitute them and see what happens. We get this term would be equal to a times alpha power n minus 1. We substituted alpha square minus 1 with alpha, and similarly in the second term we substituted beta square minus 1 with beta. But alpha power n minus 1 times alpha is just alpha power n. Similarly beta power n minus 1 times beta is beta power n. So let us substitute that. So we got f of n plus 1 minus f of n minus 1 to be equal to how much? A times alpha power n plus b times beta power n. So can you see what is this equal to? This is equal to our original function f of n. Okay, so that is the final result. So what is that we observed? We observed that the terms align perfectly to recreate f of n. This means that our entire expression simplifies to just f of n. Isn't that the neat result? The sequence maintains its elegant structure, showcasing the beauty of mathematical relationships. Congratulations! So we have uncovered the beautiful relationship within this sequence and saw how it simplifies elegantly. If you have enjoyed this problem, don't forget to like, share and subscribe for more exciting math challenges. See you in next video. Thank you.